Hi everyone, my name is Thomas Kim. Today is April 14th, 2019. This is my third episode about pointer, reference, constant in C++. In our previous episode 1, we learned something about pointer is an object. For example, int 5, int pointer ptr, address of n. ptr is a pointer that points to an int n. I said ptr or pointer is an object. Reference such as int, value reference r, and r is a reference, and r is an alias, not an object. Constant int cr n, constant value reference initialized with an object is an alias, not an object. However, constant int reference ccr5, constant value reference initialized with a literal value is an object, not an alias. So we learned such things, and our second episode intn5, int pointer ptr, and the star is a declarator if it follows a type int, a type such as int double. In this case, since type int precedes the star, this star is a pointer declarator. int value reference r, and the ampersand follows a type int, so the ampersand is reference declarator. If the star does not follow a type but precedes an expression, then the star or asterisk is a dereference operator. If the ampersand does not follow a type but precedes an expression, then the ampersand is an address of operator. These are what we learned in our previous episode. In our episode, we will learn something like this: int n5, int star ptr, and what does int star mean to C++ compiler? It has three implications. First, int star instructs C++ compiler when the pointer ptr is dereferenced with star, such as ptr. This int star instructs the C++ compiler to retrieve size of int bytes from the start of int n's address and return the value at that address. It first instructs compiler int star instructs C++ compiler that the pointer ptr is dereferenced with star, such as this. This int star instructs C++ compiler to retrieve size of n bytes, in this case 4 bytes, from the start of the int n's, this n's memory address, and return the value at that address. It means read 4 bytes, size n bytes. And another thing is int star instructs C++ compiler to regard pointer arithmetic with 4 bytes unit. What I mean is that since ptr is of type int pointer, ptr plus 1 means the address of n plus size of int bytes. So ptr1 1 means the next or the integer residing 4 bytes higher. I will talk about this very soon. The third thing, int instructs C++ compiler to implicitly define array indexing operator. So ptr 0 means the value at the address of n. ptr1 means the value at the address of n plus 4 bytes. And ptr2 means the value at the address of n plus 8 bytes, because size of int is 4 bytes. Now let's see 1, 2, 3 items in code. Start your file explorer, create your working folder. Pointer arithmetic. Double click the folder path, copy the folder path, right click your command prompt, right click properties, paste the folder path, click OK, start Visual Studio Code. Go to File, Open Folder, paste the folder path, select Folder, New, ptr arithmetic, cpp. Include IO stream, include IO manipulate, void test, pointer arithmetic, int main. So here int n0 0, int n1 1, int pointer ptr1 n0. Okay, at this point auto stream std cout auto nl n stream n0 equals ptr nl. ptr means read size of int bytes from the start address of n0 and return the value at that address. It means ptr1 int pointer ptr pointer ptr2 n1. Now what about this stream n1? We can also access like this. ptr1 plus 1 means next address, next higher address. Okay, next higher address nl, return the value. What will be this value? Sorry, I have to safeguard like this. If def msc ver, it means Microsoft compiler. If micro compiler, else and if. I will indent a little bit. If GNU compiler or clang ++ compiler. Since Microsoft compiler, in our previous episode MSVC, the stack grows from low to high. GNU, G++, and clang ++, the stack grows from high to low. Okay, so this is correct in case of Microsoft compiler, because this is low address. In case of Microsoft compiler, MSVC low, GNU, G++, clang high, MSVC high, GNU, G++, clang, low. So plus 1, we added plus 1 from this address. If we plus 1, then it goes higher address. So it returns N1. I will copy this part here. It works successfully in this case. Integer, next, higher address. Okay. In case of GNU G++ compiler, if we define like this, then we have to change the order like this. This is higher address. In case of GNU, this is higher address, high. This is low. Then we have to minus, okay, because this is high, this is low. I hope you understand this concept. In case of Microsoft, this is Microsoft, this is high. Okay, low, high, so we can increase. In this of GNU compiler, that goes from high to low. This is high address, this is low address. This integer n. So we have to minus like this. Now we test this program. I copy this function name and paste here. Now start your command prompt. dir. We try with Microsoft CL, EHSC, SC, PTR, arithmetic, CPP, FE, MEXE. This part of code will be executed M. So this value, this is retrieved properly. 0, 0, 1. Now we try with the GNU compiler. We are minus here. With the GNU compiler, G++, PTR, arithmetic, CPP, out, GEXE. GNU compiler also works like this because in case of GNU, this is Microsoft, this is GNU, high address to low address. Because we initialize PTR1 to higher address, then we have to minus 1 to access PTR2, N2. Okay, we initialize N11, N00, so this is correct code. This is called pointer arithmetic. So pointer arithmetic is dangerous because depending on compiler, it can be different. To this point, I covered this part. Also at the same time, I covered this part. We will test another one. I will fix a typo here. And one more. I will copy this part of code. Copy. And paste here. I will change test array indexing with a pointer. I will copy function name, paste it here, disable this function. Now I define int static array. This is static array. We initialize 0, 1, 2, 3, 4. Then we can count array element count. Static array element count. Size of static array. Please note that this size of operator works for static array only. You cannot use pointer this way. Then we can divide the size of int. Then we can calculate static array element count like this. For size t I equals 0, I less than static array element count plus plus I, then we will define pointer here int ptr. Then we can initialize with static array. We assigned static array to pointer. This is called type decay. Now this is equivalent to this int ptr address of static array first element. This is equivalent. Now here ptr I, we will say times like this. We are square each element of the array using array indexing operator implicitly defined by C++ compiler for pointer type. Now we can display like this. When we display, we will use C++ iterator. When we use the C++ iterator, we can do like this. For or E static array. Let's try it if it works. Then stream C++ way to index each element of array. Now let's build and run. This is GNU compiler. Wow. Say we initialize 0, 1, 2, 3, 4. It is squared like this. Now clang compiler. We can remove this option. Clang also works. Now Microsoft compiler. I will type ehsc ptr arithmetic cpp fe mexe. Microsoft compiler works. So even though we haven't defined this indexing operator for pointer, this int pointer instructs C++ compiler define indexing operator implicitly. In next episode, we will learn more advanced concept about pointers. Constant pointer to constant object and constant pointer to constant object. Please subscribe to my YouTube channel. Thank you for watching.